Hello guys, welcome back, and we will be discussing now a few problems on from probability of IIT JAM 2020, and I think it will help you guys to recap the ideas of probability that you have. Okay, so let's start. Let's try to go. I will not do the all the problems. There are around 26 problems. Okay, in from probability in 2020, and we will be discussing a few of them. Okay, until I get tired. Okay, so let's do this. So let's do the first problem of probability. So E and F are two events, and which of the following is not true? Always true. And what we have got over here, guys, that um we will use this property over here. So when you are given this property, you have to check one by one all the corresponding like well, like one by one all the corresponding like point wise each of the options step by step. So let's do this. Okay, and this seems quite natural. Some of them seems quite natural. Probability of E union F. So for this, the basics required is Venn diagram and the set and the connection. It's the probability one part. Okay, in what we follow in Cheenta. So it's like E union F contains both E and F. So that's the idea. Okay, so U union F contains E and F both, and therefore it must be greater than max of both of them. Okay, I mean like one of the P of E or P of F will be max, right? So therefore it's greater than that. So let's say probability of F is max, and therefore you get that probability of F say ye zyada hai. Okay, so therefore you get that this is true always. Similarly, let's do the other one, intersection part, that uh, intersection E union E intersection F is minimum से छोटा है. So probability of E intersection F is less than, it's a part of E, so therefore it's less than equal to probability E, and P of intersection E intersection F is less than probability of F. So therefore what do we get over here is that if X is less than equal to A and X is less than equal to B, then X is less than equal to minimum of A comma B. Okay, so this is a generic result, and we use this result in lot of times in order statistics. Okay, we use this result. So this is a really interesting result and important result. So like make this, like keep this in your mind. So I remember my time when I got into ISI, and when I got the first assignment, this first assignment contained and used this result very much. Okay, in my bachelor's first sem, yeah, first or second sem in probability theory. So you take this example in your mind ingrained. Okay, so that it can help you solve this problem. So therefore it also turns out that D is also true. Let's try to understand this probability of E union F. E union F, and probability of union F. Let's see. Observe this very carefully. Union F is equal to probability of E plus probability of F minus probability of E intersection F. Therefore, it's less than equal to probability of E plus F. And also, this since it's a probability is less than equal to 1. So since X is less than equal to A and X is less than equal to B, X is less than equal to minimum se chota hai. Okay, simple, right? So therefore, X is less than equal to minimum of this and this. So this and this. So therefore, that's what we got from here, and C is also true. Therefore, we get that A is not true. But we will not stop over here. We will not stop till the we will not stop because the problem is solved. Okay, the option is we have got. We will understand that where it's going wrong. Okay? Which is important for your concept to understand. We will not do this in an exam, but since it's a video making you understand what is happening and making your concepts clear, I must do this. Okay, otherwise I will it will be a scene on my side. So let's try to understand this. So we will use something called De Morgan's law. De Morgan's law is this, that A intersection B complement is A union A complement union B complement, and this is De Morgan's law, and A complement intersection B complement is equal to A union B uska whole complement. Okay, this is called De Morgan's law. It's a set theory law. You can easily prove that. Okay, and I'm so sorry for this. Actually, Jamboard is a very bad place to write. I think I will move on to OneNote soon. I think I will move on there. Uh, okay, maybe I'm writing it too fast. So probability of E complement plus F complement is equal to probability of E union E complement union F complement plus probability of E complement intersection F complement. Okay, and therefore you get that its probability of E intersection F complement is there by De Morgan's law, and therefore we get 1 minus probability of E intersection F, and this remains constant. And if you see that this comes naturally, that 1 minus probability of E complement minus F complement is equal to plus something is actually this probability of E intersection F. So we get this result, okay? And what we get over here is that this probability is greater than 0. So let's call this alpha and let's call this beta. So we need to show that we need to here the condition is given that beta is less than or equal to maximum of alpha comma 0. So let's take two conditions. Let's suppose it's true, okay, and we will show contradiction. So let's suppose it's true. So let's suppose that two conditions is taken. Let's say alpha is greater than 0. That means maximum is alpha. So therefore we get from, suppose it's true, then we get that beta is greater than or equal to alpha and less than or equal to alpha. Okay, beta is greater than or equal to alpha from this and less than or equal to alpha from the given condition we assumed it's true. Therefore we get that beta is equal to alpha. Therefore we get a probability of E complement intersection F complement is equal to 0. That means E complement intersection F complement is equal to phi, which means that E union phi is equal F is equal to the whole set. Okay, similarly if you take alpha is less than 0, you get that E intersection F is phi. So therefore for this to be true, it's not always true. It has certain conditions for which it will be true, not always. So therefore it will not be true always. Okay, but suppose it's given that E intersection F is 0 or phi, then you can actually sometimes show it. Okay, so that's the idea. Okay, that's the idea. So you can you learn something about this, how to apply De Morgan's law and stuff like this. But in exam, what we will do is that you will focus on these problems one by one in small aspect. Okay, it's really important to like know this and understand this in a very during the exam what to do rather than here rather than focusing on this detailed aspect. Anyways, I am glad that I am discussing this detailed aspect over here. Let's move on to the next problem. The next problem is x is a random variable and Poisson 2 distribution. What is expectation 1 plus 1 by x? The beautiful aspect is that expectation 1 by, this is the first principle problem. Okay, just basic application of expectation. First principle, if x follows Poisson 2, okay, so expectation 1 by 1 plus x will follow. Just find out the expectation. Okay, just write it down for the first principle. A summation of x from 0 to infinity will be looking like this: 1 by 1 plus x into e to the power minus 2 into e to the power x by x factorial, the Poisson wala stuff. And you just try to compare. So the beautiful part is that 1 by 1 plus x times x factorial become x plus 1 factorial in some sort of in terms of exponential again. Okay, and it goes, therefore if you just calculate this, it goes summation x from 0 to infinity e to the minus 2 to the power x plus 1 by x plus 1 factorial. And this loss of looks like Poisson, but it's not Poisson, just it's missed by one term. That is 1. That is y from 1 to infinity e to the power minus 2 to the power y by y factorial. We need to multiply half over here so that it becomes 2 to the power x plus 1. And you see y is equal to 0 is missing, so you get that it's 1 minus probability like x is equal to 0 sort of. So that is e to the power minus 2. So therefore half into 1 minus e to the power minus 2. Guys, since you're live, 3 people are live, you can ask me doubts in this section, so that if you need any help I can help you out. Okay, okay, so this is the idea, and therefore we get this C. Just apply the basic principles, not always think of formulas. Okay, apply the basic principles. It's really very helpful sometimes. So let's move to the next problem, guys. The mean and standard deviation of weights of ponies in a large animal shelter are 20 kg and 33 kg. Use Chebyshev inequality to find that x lies between 26 and 14. Let's say x is the like weight of the ponies. X is a random variable depending on the weight of the ponies. Okay, and we have to find this probability, and we know that we use Chebyshev inequality. What is Chebyshev inequality? Chebyshev inequality says that probability x minus mu by sigma is modulus greater than some k is less than or equal to 1 by k square. So therefore we have to change in that format. So mu is equal to 20 here given, and sigma is equal to 3 over given. So therefore we need to just, if you just do minus subtract 20, you get 6, and minus 6 divided by 3, you get minus 2 and 2, and you get probability x minus mu by sigma modulus is less than or equal to 2. But here Chebyshev is in terms of greater than, so you just need to do that 1 minus probability greater than 2. Now this is less than or equal to 1 by 2 square by Chebyshev. Therefore this must be greater than or equal to 3 by 4. Okay guys, very simple stuff, very easy stuff, and just apply the basic principles. Okay, just Chebyshev inequality ka definition, very easy stuff. Exercise problem, exercise like book behind book problems. Okay, So let's do problem number 8 now. Problem number 8 says that if x1, x2, x10 is a random sample from normal 1, 2 distribution, okay, and if x bar is equal to x, like 1 by 10 summation xi and x square is this 1 by n minus 1 summation xi minus x bar whole square, which is the normal definition, then what is the variance of s square? The most beautiful aspect is that if you get like very overwhelmed by the calculations involved, the beautiful part is that there's a distribution of s square. You should know this. The distribution of x bar and there's a distribution s square. This is very helpful in term also in hypothesis testing when you try to find uh, the test for mu when sigma is unknown, because you need to divide by s square. Therefore that comes that below में नीचे में chi square आता है, ऊपर में normal आता है, so it gives t test. Okay, so it's an important result. So s square follows some chi-square distribution. So s square follows chi-square 9. Not s square, but some changing s square. 9 into s square by sigma square follows chi-square 9. Okay. 9 s square by sigma square, that is 1 summation xi minus x bar by sigma whole square. This follows chi-square minus 9, 10, 1 minus 10 minus 1. Why minus 1? Because of this x bar. If it was mu, it would have been 10. Okay. Because of this x bar, it's becoming 10 minus 1. And therefore 9 s square by 2 follows chi-square 10 minus 1, and you need to know this result, that what is the variance of chi-square 10 n. Variance of chi-square n is twice n, and therefore you get that variance of 9 n square by 2 follows 2 into 9, that is 18. If you just do that by normal variance calculation, that you get that variance of s square is equal to 8 by 9. So the main idea is that property of a square. Okay, what does it follow? Chi-square. This is the main idea over here. Remember this beautiful small stuff. I'm sure no one can stop you from getting into IIT. Okay, very easy stuff, guys. Let's move on to the next problem that I have done for you. Xn is a sequence of random variables such that the expectation of xi is this. Okay, this problem is very important. This is an application of CLT, and we will understand this how. So CLT is normally is on xi minus on some xi. Okay, so now observe this is on x twice. It's difference of two things, so you can do it in two different ways. You can first apply CLT on this first, minus this first, and then subtract the final wala normal distribution, or you can take this as a random variable, which I have taken yi, because this is much easier. Yi is x2i minus x2i minus 1. Understand that yi's are all IIDs, because if you take y2 now, it's x4 minus x3, right, which is independent of y1, that is x2 minus x3, x2 minus x1. Naturally any two pairs are independent, so therefore yi's follows normal 0 1. You can understand because these are all normal. It doesn't follow normal 0 1, it follows 0 comma 2. Okay, with some variance, not normal. Okay, some distribution 2 with mean 0 and sigma 2. Okay, because variance 2, because I understand that the mean are same and the variance is 1, so you just apply variance over here, it just adds up, so it becomes sum. So therefore it becomes 0 comma 2 with mean 0 comma 2. And now here, since they're all IID, you can apply CLT over here. If you apply CLT, you get summation of yi by root n by root 2. Okay, that's what us like it's all about, and it goes in normal 0 1. Okay, that's what CLT says, because summation of xi minus n mu by n root over n sigma goes to normal 0 1. So therefore you just replace this values over here where xi is yi, and we have got this, because mean is 0, so this is 0, so sigma is root 2 and root n is there, so this goes to normal 0 1. So therefore you want to find the value of 1 by root n summation of yi, so it will go to normal 0 comma 2. Therefore this comes a solution. Just basic application of CLT, guys. Okay, basic applications of CLT. Very good. Let's do the next problem, guys. Okay, there is no next problem over here, and I think there is a next problem. Okay, this is a combinatorics problem. Okay, and this is a really interesting problem. This is for probability 1 again. A packet contains 10 distinguishable firecrackers, out of which 4 are defective. So if you think, just whenever the problems come to this type of problems come to your mind, you think, okay, maybe there is binomial and stuff. You can maybe formulate in terms of binomial, but no, it's not a binomial, because it's taken without replacement. Okay, not with replacement. So it's SISWOR, but I think it can be easily done with probability theory. Okay, so you have 10 firecrackers, and you're taking out of them which are 4 defective. So cross 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 4 and 6 right, and you're taking 3 randomly out of it. So what is the probability that all of them are defective? So therefore the probability all of them decreases is upper wala part will be total number of ways you can find out the defective parts, okay, items. It's four are there, so 4 choose 3. And the total number of ways you can take out any 3 any 3 firecrackers is 10 choose 3. Just divide it by there and you get 1/30. Okay, very simple stuff. Total number of possible cases by total number of cases total and total required. Just basic combinatorics, okay guys, nothing really huge. Okay, let's do the next problem now. If we think that I'm moving fast, you can pause the video, think, and then can move again. Okay, that's the idea. Okay, so let's do the next problem. That x1, x2, x4 are IIT random variables having a continuous distribution. Okay, this is one of the most important properties I love about random variables. Okay, we will see this how. It's called exchangeability of random variables. The idea is that we will see this example, that probability x3 less than x2 less than maximum of x1 comma x4 equals what? So understand this probability x3 less than x4 less than maximum of x1 x4. So try to understand this, forget all this, that probability x1 less than x2 is equal to probability x2 less than x1. Means what? It means that it's actually same. Why? Although it doesn't look same, because x1 and x2 are IID. So it doesn't matter that what are IID, like since the IID doesn't matter where is x and where is x1 and where is x2, it doesn't matter. Okay, they are independent. So these two probabilities are same, and this gives that therefore its probability is equal to half over here. This probability, because x1 less than x2 is half and x1 greater than x2 is half. So therefore this is equal to half, because these are the only two possibilities that we have. If it's a continuous distribution, this continuous distribution is important because probability of x1 is equal to x2 should be 0 to make this happen. Okay, that's the idea, should be 0. Okay, so let's move on to this problem now. So probability x3 less than x2 less than maximum of x1 comma x4, we get that, let's assume two cases, either x1 was greater than x4 or x1 was less than x4 was greater than equal to x1. So we do this, that x3 less than x2 less than x4 x1 and x1 greater than x4 and x4 greater than equal to x1. So two cases we divided. Okay, so now observe that these two are same because x4 and x1 are exchangeable, similarly IID. So therefore these two probability are same, and x4 is equal to x1 ka probability is 0. So therefore, I mean this condition, extra condition, x1 greater than x4 and x4 greater than x1 are same condition stochastically. Okay, so therefore it's twice of this. It's twice of this first one, say x3 less than x2 less than x1 and x1 greater than equal to x4. Now this twice of this. Now observe this very carefully. This is all about exchangeability of random variables, all about symmetry principle. Okay, it's called the symmetry principle and exchangeability of random variables, of the IID random variables. Now understand this very carefully. Observe this, that now we need to find this. Now observe that x1 greater than x4 can lie here. So we know that x3 lies here, x2 lies here, and x1 lies here. x1 greater than x2 greater than x3. Now where does x4 lie? That's the question, right? Suppose x4 lies here, or x4 lies here, or x4 lies here. So we get 3 twice into x4 lies here, x4 lies here, or x3, x4, x2, x1, or x4 lies here, x3, x2, x4, x1. 3 cases, right? And also all the cases have same probability because they're exchangeable. It doesn't matter how these random variables are, x1, x2, whatever the proportion are, whatever the arrangement are, the probability always be same. You understand? The probability always be same. And the equality doesn't matter because equality case is 0 since they're continuous random variables. Probability is 0. So therefore, all these randoms are exchangeable. So therefore, the idea is that the exchangeability criteria is important. Therefore, all these are equal. Therefore, into 3 into, let's take this first one, equality is 0. So we get that x4 less than x3 less than x2 is less than x1. Now observe that this essentially means that all the permutations have the same probability, all the possible permutations. x4, and there are possible permutations means what? This is arranging 1, 2, 3, 4, right? Say x3, x4, x2, x1. This is essentially arranging 1, 2, 3, 4, right? and therefore 24 such possibilities are there, 4 factorial. So therefore, and all of them will are disjoint and exhaustive. They will sum up to all the whole set. Therefore, what we get, sum of all the 24 equal events is equal to 1. Therefore, each of these equal events is 1 by 4 factorial, that is 24. Therefore, 6 by 24 is 1 by 4, and therefore you get the probability to be 1 by 4. This is the beauty of exchangeable random variables. I love this problem. I'm sure you must love it too. Okay, this is the one of the most beautiful problems of the paper in probability. Okay, this problem also came in ISI MStat last year. Okay, let's do this problem now. Now these problems are really easy. Now this concept comes over and over and over again in IIT. Okay, I kind of see this, observe this. So this concept is this, that if z1 z2 are IID are normal 0 1 and y is equal to z1 square plus z2 square, then probability y greater than 4 is equal to what? So you can understand if y is normal IID z1 square plus z2 square is chi square 2, but that's not the trick over here. You can see the idea is that chi square के साथ gamma related है and gamma के साथ exponential related है. So chi square follows chi square k follows gamma k by 2 comma 2. Okay, and chi square 2 therefore follows gamma 2 by 2 comma 2, which is gamma 1 comma 2, and gamma 1 comma 2 is exponential 2. Okay, this is the beauty. Therefore chi square 2 is follows exponential 2, and therefore probability y greater than 4 means integration 4 to infinity 1 by 2 into e to the power minus x by 2. You just integrate it dx, you get e to the power minus 4 by 2, which is equal to e to the power minus 2. Okay, that's it. Simple, beautiful, elegant stuff. So this property is really important. Find the connection between chi square, gamma, and exponential. I have seen a lot of problems on this. I think in 2020 in testing hypothesis, this problem was used. This idea was used in testing hypothesis to find the likelihood ratio and the criteria test rejection criteria 2 times. So it's really important. That was the most difficult problem of the paper in statistical inference. Okay, let's do this problem. Consider a sequence of independent boundary trials with probability of success in each trial being 1/3. X with the number of trials to get the second success, and probability x greater than equal to 5. You can just understand it from here. This is a negative binomial problem. Okay, if there was only one success, it was geometric problem. If it was two success or more than one success, it's sum of geometric, which is negative binomial. And therefore we get that we need to find out, but this is actually looking at like negative binomial. Don't try to apply the formula right away. Try to decode, divide, like do it from scratch. Okay, this will help you out. So two successes are there. Let's say at the kth step, you have the second success. Therefore, the first success will be somewhere in the k minus 1 steps. So we choose those steps, k minus 1 choose 1, and the probability of these two successes is 1 by 3 whole square, and the probability of failures is 2 by 3 whole to the power k minus 2. Therefore, there is a probability of x is equal to k, and if you k minus 1 choose 1 is for selecting this where the first success is there among the first k minus 1 places, and this is the normal probability. Okay, all of them are independent, therefore their product will be this, and therefore if you just like do this, it will come out, it's coming out to be this term. And if you just find probability x greater than equal to 5, you just divide this and subtract this. Okay, x equal to 1 2 3 and 4, and you can get all the stuff over here. You can get this result, and it is coming out to be 16 by 27. Okay guys, so that's it. I think I have no other problem. Oh, I have this problem. Let's see, I've done a lot of problems, it seems. Okay, so this problem tells that it's a really easy problem. It's a Bayes theorem problem. So a computer have two printers, P1 and P2. One follows normal 10,4 and another follows uniform 1,21. And we know that probability of like printer 1 can handle 40% of the task, 0.4, and printer 2 can handle 60% of the job. And if a randomness related printer is found to have completed in less than 10 minutes, what is the probability that it was handled by printer 2? Okay, it was handled by printer 2. So probability of printer 2 handled by printer 2, given that t is the time taken, is less than equal to 10. Now the idea is that we know the probability of t given p1 and given p2. Try to understand what we know. Because given P1 we know that it follows uniform normal, and given P2 it follows uniform. So we know this results. Therefore, we also know probability of P1, that is can be handled by P1 and it can be handled by P2. We know this stuff, okay? And therefore we can use this result, and therefore naturally Bayes theorem comes up. Probability P2 given t less than equal to 10 is equal to probability t less than equal to given P2 into probability of P2 by probability t less than equal to 10. Now you divide probability of t less than equal to 10 in two cases, given on depending on the situation we have, the information we have, like this. Probability of t less than equal to 10 given P2 into probability of P2, and this. It's called total law of like LOTP, which is called law of total probability. And you just put the results. We know that probability t less than equal to 10 is okay. First, let's see probability t less than equal to 10 given P2 is uniform 1,21. Therefore, it will be 9 by 10. 9 by 20, okay? 9 by 20 is the probability, and it's 0.6 is the probability of handled by P2 is this. Probability P1 is 0.4, and probability t less than equal to 10 given P2 is given P2 P1 is what? Given P1 it's normal 10,4. So therefore it's asking probability t less than equal to the mean, which is half always. That is 10. Therefore its probability is 0.5. So what do we get over here? We get this total probability, and you can find it out, and you can find it's around 0.57. Okay, that's a value. Okay, very beautiful problem, just Bayes theorem application. I hope you don't have any doubts. Okay, and I think this is the last problem I've discussed. There are another problems left, a lot of problems left. I don't know how many problems I've discussed. I hope it's very clear to you, and I'm quite excited to solve problems for you guys so that you do really good in the IIT JAM. And that's the idea, okay? And yeah, good night, and don't forget to subscribe in our channel, like it, and share it with your friends so that you get much more enjoyment in solving problems together, okay? And we have done preparation tips for IIT JAM MS and ISI MStat. Do check out our channel. We have done a lot of videos. We're doing a lot of videos for you, and do stay tuned and stay blessed. See you in the next video. Bye bye.